For your MyLab questions within the assignment for 13.4 through 13.6, we discuss special factoring techniques. What's involved in the special factoring techniques are special types of binomials that are factored using the difference of two squares formula, or binomials that are factored using the sum and difference of two cubes formulas. And we also have perfect square trinomials that can be factored using the perfect square trinomial formulas. So let's get started with the questions that you'll see within that MyLab assignment. For example, number 12, select the answer that best completes the given statement. So the screen prior to this gave you a list of formulas. This formula is for the difference of two squares. And the formula for the difference of two squares gives you the factors that are equal to a plus b times a minus b. For the next question, 36x squared minus 49y squared. And the question is, if the expression is written in the form a squared minus b squared, then a equals to what and b equals to what? So when we look at 36x squared, we know that 6x times 6x equals to 36x squared. And that's why we call 36x squared a perfect square. And we know that 7y times 7y equals to 49y squared. And that's why we say that 49y squared is a perfect square. So since we have the difference of those two terms, we know that we're using the a squared minus b squared, the difference of two squares formula. So in this respect, our a is 6x and b is 7y. For number 14, the expression a squared plus b squared can be factored by using real numbers. The answer is false. A squared plus b squared is prime. It cannot be factored. It cannot be factored. We can factor a squared minus b squared using a plus b times a minus b, but we cannot factor a squared plus b squared. Number 15, factor the following binomial completely. So we know that it's a binomial. The fact that we have an x squared is giving us the idea that we have the difference of two squares, but we just want to prove it. So if we can prove that x squared and 9 are perfect squares, and we have the difference between the two, meaning a subtraction sign, then we can use the formula for the difference of two squares. So we know that x times x equals to x squared, and we know that 3 times 3 equals to 9. We have the difference between those two. So using the formula a squared minus b squared, where our factors are a plus b times a minus b, simply means that we're going to use x for a in the formula, and we're going to use 3 for b in our formula. So we factored x squared minus 9 into x plus 3 times x minus 3. Let's go to the next one. Factor the binomial 9x squared minus 25. So again, the fact that we have x squared really is giving it away that this is going to be the difference of two squares, but we just need to prove it first. So we have 9x squared. Well, we know 3 times 3 is 9, and we know that x times x is x squared. So we say that 3x times 3x does equal to 9x squared. So we have a perfect square here. And we know that 5 times 5 is 25. We have the difference between those two squares. So we can use the difference of squares formula. A plus B times A minus B, where our A is 3x and our B is 5. So 9x squared minus 25, using the formula, will give us 3x plus 5 times 3x minus 5. Let's factor 9a squared minus 4b squared. So let's go ahead and find the factors that will give us these two perfect squares. So 3a times 3a, that gives us 9a squared. 2b times 2b gives us 4b squared. So we know that we're using the difference of two squares formula, where a plus b times a minus b are our factors. So we say that our a is 3a and our b is 2b. So 9a squared minus 4b squared equals 3a plus 2b times 3a minus 2b. Now with number 18, we clearly are not looking at perfect squares because we have x to the third power. So this takes us to the sum of cubes, the sum of two cubes, which is the formula where we have a to the third plus b to the third. And the sum of cubes formula gives us a plus b times a squared minus a times b plus b squared. As long as we can identify our a and b, we simply plug those values into the formula and then that factors. So let's look at these two terms. So we're seeing that we have z to the third power. So that just means that z times z times z gives us z to the third. That's what makes it a perfect cube. We have 27. 3 times 3 times 3 equals to 27. And that's what makes 27 a perfect cube. The fact that we have three identical factors that multiply to equal to 27. So I'll say that my a is z and my b is 3. So we're going to go over here and we're going to plug those values into the sum of cubes formula. So for my a plus b, I'm simply going to write z plus 3. And then we go over to the rest. And we're going to take a, we have a to the second power. So our a is z. So when I square z, that will be z squared minus, next I have multiply a times b together here, a times b. So a is z and b is 3, right? Z times 3 is simply a 3z plus, and then we're going to take our b and we must square b. So our b is 3. So when we square it, right, 3 squared, that gives us 9. So the answer to factoring z to the third plus 27, that's equal to z plus 3 times z squared minus 3z plus 9. The next binomial, 8x to the third minus 1. So again, we are ruling out the difference of perfect squares because we have an x to the third. So that means we should be looking for perfect cubes. Since we have the difference here, that means that we're using the difference of two cubes. And the formula for the difference of two cubes is a minus b times our a, which we square, plus multiply a times b, plus our b, which is squared. So let's make sense of these two terms being perfect cubes. So for 8 2 times 2 times 2 is 8. And then, of course, we have an x to the third. So we can say that 2x times 2x times 2x is proof that 8x to the third is a perfect cube. Then we have a 1. Of course, 1 times 1 times 1 proves that 1 is a perfect cube. And we have the difference between the two. So we know that we're using this formula, a to the third minus b to the third. So now we just simply label our a as 2x and our b as 1. And we go here and we start to plug in our a's and our b's. So we have, for the first part of our factors, we have a minus b. So that's 2x minus 1 times, and then we have our a, and we must square it. So that means we're taking this 2x, right here. We're taking the 2x, and we are squaring it, right? So I'm not just placing a 2 as an exponent. I'm squaring 2x, meaning 2x times 2x, right? So that gives us 4x squared plus. Then we're multiplying a times b. So 2x times 1 is simply a 2x here, plus, and then for our b, we're squaring it. So, of course, 1 is our b. 1 squared is simply a 1. So our final answer is 2x minus 1 times 4x squared plus 2x plus 1. So moving on through section 13.6 is where we start to take factoring and we apply that concept to solving equations involving factoring. So first, with this question, if a b equals to 0, then we say that a equals to 0 or b equals to 0. That is the correct answer to this statement. The next question, factoring is an important method for, and I just mentioned it, for solving equations, And next we're going to look at examples of using factoring to solve equations. We have t squared minus 5t equals to 0. So it's going to be important that you identify the type of polynomial you have in the equation so that you can determine which method you're using. This may appear to be the difference of two squares, but it's not, because look at 5t. 5t is not a perfect square. So the only way I can factor this polynomial is by using the GCF. So we're factoring using the GCF. And t is the GCF. So when I factor the t from both terms, that's going to leave me with t minus 5 in parentheses. And it's still an equation. So here's how we solve by factoring. Once we factor the polynomial that we have on the left side of the equation, we take each set of those factors and create an equation out of the factors where the equation is set equal to 0. So for example, t is a factor that I set equal to 0. T minus 5 is a factor. I set that factor equal to 0. Now, t equals to 0 is really already solved for, so we really don't have to do anything here. We just know that 0 is a solution. But t minus 5 is an equation that must be solved. So to solve for t, I'll simply add 5 to both sides so that I'm left with t equals to 5. And so 5 is the other solution that we have. So we separate our answers with a comma in MyLab. Right? So you just simply type 0, 5 for your answer. Let's look at the next equation. We have 10x squared minus 7x equals to 0. So we look at the polynomial that's on the left, identify the type of factoring method we're going to be using. So it is a binomial. It's not a perfect square, right? 10x squared is not a perfect square. 7x is not a perfect square. So the only thing that I can do with this type of polynomial is find the GCF. And the GCF is x. Once I factor x from both terms, that leaves me with 10x minus 7 in the parentheses here. So we have x times 10x minus 7 equals to 0. So again, I'm going to take both factors. I have an x as one factor. I have a 10x minus 7 as another factor, and create equations out of them. So this one I set equal to 0, and this one I set equal to 0. So x equals to 0. That's a solution that we already have. So I'll put 0 there. That's a solution. No solving really involved here. But here we have a two-step equation. So I'll start by adding 7 to both sides so that I can bring down my 10 times x equals, and bring down my 7. And then the last step is to divide both sides by 10 such that I end up with x equals to 7/10. And 7/10 is the other solution. So 0, 7/10 is the answer. Now the next equation has a trinomial as the polynomial. X squared minus 14x plus 40 equals to 0. So here we're just using a regular trinomial factoring method, right? We don't have an a, right? We don't see that there's a number in front of our x squared. So it's just a regular trinomial. We just need to know what factors of 40 will add to give us a negative 14. So once you do all of that work on your paper, you should end up with x minus 4 times x minus 10. So we have our two factors, and that's set equal to 0. So we're going to take the x minus 4, and we'll take the x minus 10, create equations out of those by setting them both equal to 0, and then solving. So to solve for this equation, I simply add 4 to both sides, where x equals to 4. So that's our first solution. I'm just going to put it here. And the second equation, I will add 10 to both sides to solve for x, and x equals to 10. So we have 4, 10 for our solution there. For the next equation, so again, we're doing different types of equations that have different types of polynomials. So different methods of factoring those polynomials. So for this trinomial, we have an a here. We have a leading coefficient that's not 1, but we have a 3 here. So you're either choosing the factoring a trinomial using the grouping method / AC method, or you're using a math trick that we talked about in class called the double A method. Whatever method you choose, once you have factored this trinomial, it's going to take you a few moments to factor, then you should have for your answer 3d minus 1 times d plus 5 equals to 0. So we have 3d minus 1 and our d plus 5. Both will be equations that are set equal to 0, and then we solve. Here I will add 1 to both sides first, and that's 3d equals to 1. And then divide by 3 on both sides, where d equals to 1/3. So I have my first solution is 1/3. Over here, I simply subtract 5 from both sides to solve, and d equals to a negative 5. So I'll write my solution in MyLab as 1/3, negative 5. For the last equation that we're solving, first we see that this equation isn't set up in a standard form as the other equations, meaning the equations are not set, this equation is not set equal to 0. All right, so what we're going to do is we're going to make it set equal to 0. I want to make sure that this side of the equation has a 0. So I'll do that by subtracting 4x, and I'll subtract 32. All right, that will zero out this side. But what does that mean for the other side of the equation? Well, that means I must also show the subtraction of 4x and the subtraction of 32, right? What I do to one side, I must do to the other. So just doing this step here, now we have our trinomial on one side and we have it set equal to 0. So then we factor this regular trinomial. So take your time, factor that out. Once you factor this, that factors into x minus 8 times x plus 4 equal to 0. So I'll take the x minus 4 and the x minus 8 and the x plus 4, create equations out of both, set equal to 0, and then solve. So I will add 8 to both sides, and x equals to 8. Now subtract 4 from both sides, and x equals to negative 4. So I will write my solution as 8 comma negative 4. Now, the last question within this section that you have does work with a right triangle. Therefore, we're using the Pythagorean theorem in order to solve. So, we have our hypotenuse, which is our C, that will be the longest side of the triangle. And then we have the other sides of the triangles, and we can call these legs, right? So our hypotenuse is the longest leg here for C. A and I have B. So we have the Pythagorean theorem. A squared plus B squared equals to C squared. When I simply take our A, B, and C and substitute that into this formula, that gives us our A, which is x minus 7. Going to square that, plus B is x. So we're going to square that and set that equal to C, which is x plus 7, and we're going to square that. So multiplying x minus 7 squared gives me x squared minus 14x plus 49. And we already have the plus x squared here. On the other side, multiplying out x plus 7 squared, that gives me x squared plus 14x plus 49. Now I'm going to combine like terms on this side of the equation. And the only like terms that can combine are the x squared and the x squared. So when I add those two x squareds together, that gives me 2x squared minus 14x plus 49. Okay. And I'm just going to bring everything else down, like so. Now the next thing that I want to do, I want to again make sure that I'm putting the equation in standard form. So I want to zero out the right side of this equation. I can simply do that by subtracting x squared, subtracting 14x, and subtracting 49. Now it's equal to 0 over here. But I must also subtract x squared, subtract 14x, and subtract 49 from the opposite side of the equation. Because what I do to one side, I must do to the other side. Now over here, on the left side, when I subtract, right, I'm combining like terms. This leaves me with x squared, or you can say 1x squared, minus 28x. And then, of course, here, those terms zero out. Now we can move forward with solving by factoring. So we are going to factor the GCF, which is x, and that leaves us with x minus 28 in parentheses, equal to 0. We have one factor, which is our x, and we have our other factor, which is x minus 28. Set both factors equal to 0, like so. And we have x equal to 0 here, which we're not going to include because, of course, we're talking about distance and length. So I can't say that any of those lengths are equal to 0 at this point, right? But over here, when I add 28 to both sides, that gives me x equals to 28. So let's look at that and use x equals to 28 as our answer within this right triangle. And let's see how it works. So if x equals to 28, And we go back to our triangle and we put in 28 minus 7 for A. We put 28 here for X. And we put 28 plus 7 for C. So that will give us 21 for A. And we have, of course, 28 for B. And 35 for C. So A squared plus B squared equals to C squared. Let's see if that checks out. 21 squared plus 28 squared equals to 35 squared. So 21 squared is 441 plus 28 squared is 784 and 35 squared is 1225. When we add 441 plus 784, that does equal to 1225. So the answer is correct. Where x equals to 28, it definitely makes this a true statement.